So far, we have discussed combined cycle, okay? And we are going to talk a little more about the combined cycle analysis in the following example. But there's another thing that we have to think about. Do we only need electricity to run our community? Your answer should be no. We also need heat to heat up your house, and you need hot water. And not only the residential area, we have plants and factories that also need a certain heat and even steam. Okay? So can we also, then the next question is that, anyways, we can generate a steam. Okay? Now, what if we make use of that steam not only for power generation, but also for something else? So that is the motivation of the cogeneration system. So how we run the entire system is almost the same as combined cycle. We need a gas turbine and we have to burn a fuel to run this gas turbine. And by using the exhaust gas and at the HRSG, we also can generate a steam. And also, sometimes we need an auxiliary boiler to make that steam quality more higher, to higher temperature and higher temperature in a superheated regime. Those steam can be used to generate a power. So now, if we connect that steam line to generate a steam turbine generator, then we also can generate electricity in addition to the electricity generated by the gas power cycle. But at the same time, that steam can be also used for something else, like plant or factories. For example, that steam can be used to run the absorption chiller. I'm not going to talk about it, but that absorption chiller is like a big scale, refrigerator. Okay, and that is being used for like a big factories and so on. Okay, and steam is needed to run it. Or this steam can be used in a residential area for the heating of the house or supplying hot waters. Now, why is that cogeneration attractive to us? So let's try to compare two different cases. Again, our society needs both electricity and heat. Okay? So now let's assume that we have two separate facilities. One facility generates a power, and another facility generates heat. Okay? If we really run these two facilities traditionally, then we need two facilities, and each facility may need a gas or as a fuel. So let's assume that this power generation facility consumes $1 natural gas. Usually gas power or any kind of power generation system has its thermal efficiency around 35%. What it means is that only 35 cents of $1 natural gas can be used to generate a power, and remaining 65 cents should be gone as a wasted heat. Now let's assume that we have also another facility that supplies heat to our society, and this facility needs around $1 natural gas. And usually to generate a heat, we have efficiency of approximately 70%. What it means, by burning out $1 natural gas, around 70 cents can be used to generate a steam to supply heat to us, and remaining 30 cents will be wasted as a waste heat. So if you combine them together, in entire society, we burn $2 natural gas, and we waste $1 just without doing anything. We only get $1 benefit by burning out $2 natural gas. So, overall efficiency should be 50%. Then what if we use a cogeneration? Okay, so now let's say that we have a cogeneration facility. Now let's try to burn out $1 natural gas. Out of $1 natural gas, still the power generation part takes around 35% thermal efficiency. So 35 cents can be used to generate a power. Now, remaining 65 cents, instead of wasting that energy to the outside, we use that waste heat to generate a steam. And this steam generation efficiency is again around 70%. So what it means is that out of 65 cents, approximately 45 cents still can be reused to generate up steam or hot water. So that can be supplied to the society. So only 20 cents is being wasted. So by burning out $1 natural gas, we get 80 cents beneficial to us and we waste only 20 cents. So overall efficiency is 80%. So 50% in a traditional way versus 80% in cogeneration concept. So which one would you choose? The answer is obvious, right? So that's why in these days, when you build up a new town or develop a new town, then that whole town is supported by one big cogeneration power plant to supply the electricity as well as heat to run that community. Okay, so that is these days what we are doing.